Hi and welcome back to another video. As you can see, I'm awesomely dressed, and this video is also going to be awesome because we are visiting the PowerColor factory. And I had the opportunity to visit this here during Computex, and we are at the first section, which is basically the incoming quality control. So yeah, I'm standing next to the first machine, and I will try to take you with me, and I'm not quite sure what I'm going to see, but I think it's going to be very interesting. All right, so for this first machine, it's validating SMD components, which is quite interesting. So we have those big rolls of SMD parts. Could be some, looks like some capacitors. Can be like here we have some inductors, and they're put onto this trolley, and then they're moved into this machine right here, stacked in there. And so this arm is always grabbing one of them and putting them in here. So from there, it goes in here, as you can see, and that's an X-ray machine. This X-ray machine will count the amount of parts and if the part is the correct part. That is what we can see on the screen right here. So all these, you can see it counted 9,432 parts. And after it's counted correctly and validated, this machine will put a QR code onto this roll, and then it will exit from here, fall into this box. And on this QR code we will have the information if the part is the correct part, what is the part, and what is the quantity of the part. So that is the first step, just quality control to see if the part they ordered is the correct one and what's the quantity of the part. So now we're going to IQC, incoming inspection. So what they're doing here is they're basically validating if any of the incoming parts, and this could be a cooler, like in this case, which they order externally, contains any hazardous materials or elements. So they have to take apart the entire cooler into, like, as you can see, the tiniest pieces. They even have to like break off a fan blade or like a screw or anything, and then it goes into this machine, which is kind of interesting because we have the same machine at Grizzly, not the same vendor, but it's a it's an X-ray machine that can scan if there are any hazardous materials inside. So for example, it's checking for chromium or something, some material that could be hazardous, and it's checking for parts per million and see if it's passed or not. And they actually have to test this for every tiny piece, even a screw. Here they are testing and validating those incoming SMD parts. That mainly also depends on the quantity, how many is of one of those rolls, and how many they ordered, and what is one batch. So here, they are right now testing some inductors that could be placed on the graphics card, and they're obviously also validating and testing resistors and capacitors to check if the capacity is right, and they have to follow international standards. So just for an example, if they, let's say, have a batch of 10,000 pieces, then they have to test 200 of them, and if one fails, they have to test another one. If two fail, they have to basically return the entire batch. And yeah, that shows that there's a lot that goes on just before you can even start with the manufacturing process. Same as the SMDs, also the PCBs have to go under quality control. It's the same kind of standard, so they still have to do the same thing. If they order 10,000 PCBs, they have to test a portion of them. And in this example, they're testing the flatness of the PCB. So they have this granite table, and if everything is correct, like this one, you can like pat on the left and right, it basically doesn't move. This is just an example because that would be a faulty one, because you can see if I just press on here, it's easily checkable that this is not entirely flat, and this would be rejected because that would be or could potentially be a problem for the pick and place machine later in the production. And then they also do check of the size of the PCB, so they basically measure the length of the PCB and check that it can go a max of 0.5% difference in length, and if everything is fine, they can continue with production. Here we are in one of the RMA rooms, because obviously sometimes you have some failures on some cards, and that's one room of the RMA department. This is where they are currently reworking some GPUs. So on that one, he's waiting for the GPU to heat up so he can actually remove the GPU. Right here next to me, he is right now putting a new GPU back on this PCB. I think he just finished it from what I could see. And you can even, with the camera, like look underneath the GPU, see the solder balls and everything, see if they're perfectly aligned. Unfortunately, I'm not quite sure what he's doing right now when it comes to the steps, but yeah, let's wait and see. So yeah, that took longer than expected. He is now removing the GPU from the PCB. I think it took like 3 or 4 minutes. And yeah, he carefully places it down and then afterwards checks the PCB for some kind of potential failure. He's right now reballing a GPU. The first step was adding solder paste with this stencil, so every single pad is covered with some of the solder paste. That then holds the balls, so he then like now adds the additional stencil on top. That helps to align the new BGAs. He's done now with the soldering process of the new BGAs, and I think this also took like 2 or 3 minutes to heat up. That's how he aligns the new balls on the GPU, and he has to pay attention that on every single spot that there is one ball. And that's the end result. A GPU with freshly baked balls on the back. Before we enter the assembly line, the employees have to be tested on ESD risk. So they also wear special ESD shoes, so basically they are grounded, and then he has to be tested if everything is okay or if there's like an ESD or like static risk. Before I'm allowed to enter this clean area, I have to take a shower. And now we are in an assembly line, the room where the magic happens. This is where new graphics cards are born, and like honestly, I'm still completely flashed that I'm allowed to be here and like shoot and film everything so open. I don't even have to censor anything. It's like completely insane, and I cannot thank PowerColor enough for this opportunity. This is like mind-blowing. It starts with the PCBs here, so you can see they're vacuum sealed. They have humidity indicators on here because that would be a danger to the PCBs. That's why they're all like vacuum sealed in individual packages, have humidity indicators on it. And also if we zoom on here, you can see that they always have humidity below 60%. You can always check that. What I also found interesting is that on here, these boxes contain GPUs. So here we have trays full of new GPUs. As you can see, RX 6700 XT AIB inside here. So 60 GPUs, as you can see, quantity is also vacuum sealed, and I guess also this part right here is probably to catch like any kind of moisture, as you can see. And maybe I can ask them to open one of these later so we can look at a lot of GPUs. PCBs start from here, they're stacked inside these trays. And then the first step is the soldering mask machine. You might be able to see it underneath there. One of the GPUs was just put in, and then the solder paste is applied through this stencil by this machine. So you can see all the paste in the back, the solder paste. I will try to record it once more. So if a new PCB just arrives. So this way the solder paste was just put onto the PCB through the stencil, and the PCB is now ready to move to the next machine, because now with the applied solder paste it can carry the components. After the solder paste was applied in this machine, it goes through this channel to this machine, which is the first quality inspection, and it will check if the solder was applied correctly, so the solder paste. This is happening on those like blue things on the bottom, and it's checking the height and the quantity and also the shape, if it was applied correctly on every single spot of the ones you can see. And it can also communicate with this machine. So let's say you have an area right here or right here where there is maybe not sufficient amount, or it looks maybe wrong. then this machine will communicate with the printer to adjust for the next batch accordingly. After it passed the inspection, it will leave the machine, and you can see on the spots where you usually have the resistors and capacitors and everything, you have the solder paste on here. And after waiting in this line, it will continue in the next machine, which is a pick and place machine. I can tell you that's going to be completely insane. So I'm just starting with an overview here, and you will see once the machines start moving, once like the next step is hit. Look at this. Have all of these pick and place machines working together, and that's where all the tiny components will be fitted onto the PCB. So here again we have those tiny rolls that contain all of the SMD components. Those are also the rolls that we saw earlier that were inspected in the X-ray, that contain the resistors and the inductors and everything. And these machines take the components out of these rolls and put them onto the PCB, and then they're stuck to the solder paste. And one of those are actually the best and like most expensive machines you can buy right now. That's why they are also very proud to show this. And they told me that the ones that put the tiny components on there, the quick ones, they place 77,000 pieces per hour. So once the machine is running, you can see that it's taking the small parts from these rolls. They go in here into the machine, and then they're placed in here. I cannot believe that they brought me a chair. I can go higher and film from up here. They even turned off the lights so we can film in from the top. It's just completely amazing, but now you can see maybe better how the two arms are working together, picking up the parts, and then very efficiently, very quickly, and extremely precise puts them onto the PCB. This machine is the last one in the production line of the pick and place, and it's placing the bigger components. Usually it would also put on the GPU and the memory, but right now they're only making back sides of the PCB, so unfortunately we cannot see that, but essentially it's going to be the same. But you can see there are inductors on here and some other ICs, I guess BIOS chip it could be, that this machine is currently doing, and we'll shortly place it onto the next PCB. So next PCB coming in. The machine is, I think, placing maybe 2 components or 3 components. And then here we have the PCB with all the components ready on the backside. Now that all the components are in place, they are ready to be soldered, which happens in this refill oven. It's a massive machine that contains up to 15 temperature zones. Currently it's programmed with 12 temperature zones, as you can see on here. So it starts with zone 1, so for example with 140 degrees Celsius, and it goes up to 275 degrees Celsius, just following this temperature curve, which is the solder curve. That depends on the components that are used on the PCB, on the quantity of parts that are on there, how big these parts are, and then every single model will have their individual solder curve that's going to follow inside this machine. After the soldering process, all of the parts are inspected. For example, this is a 0402 capacitor. And there are a lot of these capacitors on there, and also ICs and everything. And this machine has a special 3D camera that is checking every single component on there and checking the solder quality. So you can see on here, on the side, that's the part, or it's part of the solder. And this machine is checking if every single component is soldered on correctly. Every single SMD, every single capacitor, resistor, IC, everything. After the inspection is passed, the PCBs are leaving that machine, and then they're being sorted into passed or not passed. So far, there are no PCBs that did not pass, and if they didn't pass, they can go on this place right here and do a manual inspection, see if there's any kind of defect, like a solder defect or something, and could theoretically also rework it. But I think it's a pretty good sign that nobody's sitting here. And after they're done, they're sorted in these trays and then stacked in here. And you can see all the finished PCBs. So that's going to be a good amount of graphics cards right here. And this would be the PCB completely assembled on the backside, ready to go. You can still see that there are the parts on the side that still have to be broken off, but apart from that, that would be the finished PCB when it comes to the backside. Unfortunately, we could not see how the GPU is put onto the front because they're not making that right now, because they're just making the backsides. But in the end, it would be exactly the same process. It's, in the end, just a much bigger processor, like a bigger IC than what you would have on the back. This is the front side of the PCB. What I did not mention yet is that you have these pieces right here, the one on the bottom left, and this right here you can even see conveyor direction. So that is the direction the PCB is going. And on these edges right here and here, the PCB is handled inside the machine. And after the entire PCB is processed from front and back side, because right now it's only like processed from the back, but once it's also populated from the front, these parts are then later cut off. After the entire card is processed and also the GPU is on there, they also have to inspect if the soldering of the GPU and memory is done correctly. And that's done in this machine, which is an X-ray inspection machine. And that's going all over the card, because obviously what we already saw earlier with like, I don't know, capacitor, some small SMD part, you can look from the side. But let's say you have a GPU or like memory, you cannot look underneath this. So that was the GPU. And with this, they can inspect automatically if all the solder balls are where they should be, because otherwise you cannot look underneath the components. That would be the GPU area. They can even do 3D rotation, so you can see all the solder joints and even the parts of the PCB, the vias and everything you can see. And obviously not every single one is checked this way. They check by industry standards and check like a certain amount from each batch, because that obviously takes a lot of time if you go through this. Most of this is automated, but if you want to check specific parts like this in this 3D way, then it has to be done by hand, which is a quite time-consuming process. And if this would happen on every single one, then we would have a serious GPU shortage. So for your orientation, that's where we've just been and filmed all of that. So we entered all the way on here, and the PCBs went through here, through the solder mask and through the like pick and place, through the soldering, and ended up in here. What I wanted to talk about is the soldering mask machine that put on the solder compound. That happens in here. And if we go over there, that's, by the way, the room where we just went for the X-ray inspection. We have the solder stencils that are stored in this room. It's quite a lot of them, obviously, for every single PCB and model. They have these kind of stencils. And to also make sure that there is no issues with these stencils, because you could see that the machine is going over this back and forth all day long, obviously there will be wear on those stencils. So they also have to check that, which is done in this machine. And in here they're inspecting all the tiny holes inside the stencil, check if the size is correct, and also they measure the height of the stencil, because it's going over there all day long. And if there is wear, it could mean that the stencil is getting thinner, which means then in result it would apply less of the solder paste. So they also have to check this every single time after they change the machine. And don't be surprised that there is a good amount of space here. That's because they're just on the way of building a second assembly line in this room right here to make even more GPUs. This is the assembly line where actually the entire card is assembled. It all starts with a visual inspection. So all the cards arrive in here in this box, and then they are visually inspected to see if there's anything that maybe happened in a previous step. That's why visual inspection is necessary. Then on here, as you can see, the card is cleaned, and also these tiny pads are applied to the back side. So on the back you have the screw holes, and around those screw holes, to protect the PCB, these like plastic sticker washers are put on the back. After that, you can see all the cards are going on this line on here. Next step, card is put on these small benches, and then they use the torque screwdrivers to, in this step, attach the I/O panel. And also they're like validating if the torque screwdriver works like every single day, at least twice, just to make sure that everything is correct, because even if you set it to the correct torque, there could always something go wrong. After that, the backplate is mounted on here. So first, obviously, the backplate is mounted on, or put on this small bench. And then the card is put on top. First, between that, they attach the cable to the back for light, in that case, and then it's screwed from the front. Next step, another visual inspection, and additional screws to hold down the backplate and additional fixtures. And in this step, the thermal paste is applied. She's using a stencil and then wipes with the thermal paste across, and then you get this like perfect pattern for the perfect application. Prior to that, they used a different method without a stencil, so they just normally applied it, which was not that good, didn't lead to the best results. So they improved the process. This is now performing much better. And they're even working on improving this further with this machine, which is an automated thermal paste application machine. And with this, the step she's doing, the machine will do, to make sure it's like extremely precise and you will not have issues with the thermal paste application. What I also like is that we see a lot of these signs here that you're not allowed to film or photograph anything, but they basically told me, go ahead, do whatever you want, and that's something I extremely appreciate. Continuing with one of the crucial parts, which is the cooler installation. The cooler arrives from the cooler manufacturer. It has the thermal pads pre-applied, so she only has to remove the film, the protective film that is on the cooler, and afterwards just checks again if everything is sitting correctly. And here you can see the cooler with the pads and the protective films on there that she has to remove first. And the cooler is not yet fixed. That's happening in the next step again. So she's taking the card with the pre-applied cooler that comes on this belt. She puts again the card in the fixture, make sure it sits firmly, and then starts again putting the back plate and putting all the screws to fix the card to the cooler. Following that, we have another visual inspection to see if everything went well, to see if all the gaps are correct, if all films have been removed that have to be removed, if the cable is in the right place, if all the connectors are in the correct area. And then it's time for the GPU to start up for the first time. They're put in these benches, so just pretty much normal benches. They use some risers for easier mounting. And then the card is powered up for the very, very first time, simply to check if it displays or if it shows a display signal. And after this is confirmed, the card continues for testing. After the card woke up for the first time, 10% of these cards go to the burn-in test, which is basically Furmark and Unigine Heaven. They record all necessary information in this tool. So for example, you have the serial number, you have the edge and the hotspot temperature to check if there's any kind of issue. And this test is running for a duration of 24 hours. But obviously you cannot do that with 100%. That's why only 10% go through the extreme burn-in test for 24 hours, because otherwise you would need so much space. Still, 100% of the cards are tested, not for 24 hours, but for a bit over an hour. So they run through different benchmarks. As you can see, some 3D marks are running right now on these cards. This card is already finished and it shows passed. It takes a little bit more than an hour, but they're testing 100% of the cards to make sure they are running. So that arrival from the factory is kind of impossible. Obviously, there's always something that can go wrong during transportation, but at least in this state, they can make sure that all of them were working. Apart from the testing I just showed you, they also do aging and reliability testing. That's why you have a lot of different and also older models on here. For example, this card has been running since March, and that's simply to see how are the cards affected over time. Like what does happen, because obviously when, let's say, AMD launches a new card, there is no experience with this card for how it looks like in 2 years. And that's what they try to replicate here. That's why they put on the cards very early and see how reliable are they, how do they age over time. After all this effort and testing, the last step that has to be done is the simple packaging. So there is a last inspection that's done with the card to just check if everything is all right. The card is put onto the belt and then just goes to a normal packaging. I don't think that's that unusual, but you can see those are going to be a lot of RX 7900 XTX Hellhound cards. So they go in the box in the ESD packaging right here, and then that's your new 7900 XTX. And that's how a graphics card is made. And like, this was so insane today because we're rushing through this factory tour, trying to record as much as I can and also give you the same impression that I had there, because like seeing everything, the processes and the machines and everything was so impressive, and I hope you could also get the same kind of impression that I had. Thanks again very much to PowerColor for the opportunity to be there to shoot this video and show you how these things are built. Thanks for tuning in. See you next time. Bye.